Quick, graph y equals 1/2 times the cosine of x by hand, two different ways. This is part of the family of functions series. You will need paper and straight edge. We suggest you create grids similar to these ones at the right as needed, and press pause as needed anytime during this video. The first way is with the cosine dance. Recall the graph of one wave of the cosine function. Note the 5 key points of interest. These key points are affected by the parameters in the equation. In this case, there's only one parameter, and that is 1/2. So that's going to multiply each y value by 1/2. The x coordinates are unchanged by that parameter. So the initial point at a maximum for the cosine is at 0, 1. That's vertically shrunk by this factor of 1/2 to be at 0, 1/2. So we'll plot that point. The end of the first period point is normally at a maximum at 2 pi, 1. Also vertically shrunk by a factor of 1/2 to be at 2 pi, 1/2. So we'll plot that point. Halfway between the beginning and end of the period is a minimum value, normally at pi, -1. Multiplying that by 1/2, that becomes pi, -1/2. Halfway between a max and a min is a point of inflection at pi/2, 0. Multiplying 0 by 1/2 keeps it the same at pi/2, 0. So we'll plot that one. And similarly, at the other point of inflection, that's going to remain at 3 pi/2, 0. Pause is needed. So we're going to connect the points as a cosine wave. Concave down, concave up, concave down. This is one period of the cosine wave. We're going to duplicate that in the negative direction by going back each key point 2 pi. This point of inflection, the minimum goes back 2 pi, the next point of inflection, and now we're ready to go ahead and complete the wave. Comparing that to the parent function that's in blue here, y equals a cosine of x. The blue coordinate times 1/2 is the green coordinate, not just here, but at every single point. Pause is needed. Some terminology or vocabulary. The amplitude of a wave is defined to be this: the maximum minus minimum value, all divided by 2. So for the cosine wave, the amplitude is, well, the max is 1, the minimum is -1. And when we subtract those, we get 2 divided by 2, which is 1. So the amplitude of the cosine curve is 1. You'll also notice geometrically, the amplitude is the distance from the maximum point to the line containing the points of inflection, right here, or from the min point to the line containing the points of inflection. So what is the amplitude for y equals 1/2 cosine x? Pause is needed. And again, this is the definition that I just showed you. The max and min are 1/2 and -1/2 respectively. And when we subtract those two numbers, we get 1 divided by 2, which is 1/2. That is also the distance from the max to the line containing the points of inflection and minimum. Pause is needed. Second way is with a table. So we'll start with our unit circle values on the axes. Please complete the table. Pause is needed. And those are the values there. Creating a second table in green. We're going to multiply each of the y coordinates by 1/2 only, meaning the x coordinates remain unchanged. So we'll just fill those in. 1 times 1/2 is 1/2, so we'll plot the point 0, 1/2. 0 times 1/2 is just 0, so pi/2, 0. -1 times 1/2, -1/2, pi, -1/2. 0 times anything is 0, so 3 pi/2, 0. And 1 times 1/2 is 1/2, 2 pi, 1/2 is the maximum for this particular graph. Connect the points as a cosine wave. frown, smile, frown. This is one period of the wave. Let's plot another one to the left by going back a period from each key point. And there's our cosine wave. We'll compare it to the parent function in blue, and you can see that the green is half of what the blue is as far as the y-coordinates are concerned. Now you try one. Graph y equals 3/4 times the cosine of x. Use either method or both for the practice. Also mention what is the amplitude. Pause to do so. And here's your answer in green compared to the blue cosine parent function. The amplitude is 3/4.